Let us see how to solve this particular histogram problem. This is the IGCSE problem. So first let us understand what histogram is. If you look at the figure, it looks very similar to a bar chart. The only distinguishing feature between a bar chart and a histogram being the bars are not of uniform width. In a bar chart, the bars will be of uniform width, meaning all the bars will be same thickness or width. But here you obviously see that histogram may have sometimes, but typically it can be different. And in a bar chart, you have gap between the bars, whereas the histogram is continuous. So this is for representing continuous data. And normally in a bar chart, on the y-axis is always the frequency, that is the number. But in a histogram, you see that the frequency density is how many in this particular frequency. So it is like that. It's something like population density. If you take a particular area, how many people are there, how much population. So let us see how to go about this problem. So this shows, the histogram is showing the weights of all babies born in one day in a hospital. So we see the weight, whatever is the measurement in question, whether it is the time or the weight or the height, is usually represented on the x-axis, and always the frequency density is along the y. It's in a grid, and there are even minor grid lines. So for us to take out data is not a problem. So part A says 5 babies weighed between 2.8 and 3 kg. That is this first bar. 2.8 it starts. You notice that the x-axis need not always start on 0. So the minimum weight is 2.8 kg. So from that to 3 is the first class interval. And it says 5 babies were born. If you notice something, frequency density is frequency by class width. Frequency is the total number, and then that divided by the class interval will give frequency interval. If you notice, each one of these is a bar, correct? So the frequency density is the height and the class interval is the width. So this becomes a rectangle. When you multiply the height and the width, the height is actually the length here. The length into breadth should give the area or the number occupied in this, correct? So when you multiply this and this, what you will get is actually the frequency. That is the interpretation. Now it says 5 babies weighed between this. So which means the frequency of this particular bar is 5. So what does that mean? Frequency density should be 5 divided by, from 2.8 to 3 is just 0.2. 5 divided by 0.2 is 50 divided by 2, 25. So since the y-axis doesn't have a scale, our first job is to find out what marking this particular bar is. And we got it that this is 25. If you notice, 1, 2, 3, 4, 5. There are small 5 grids which make up to 25, which means every small grid is 5, 5 each. If this is 25, this marking is 30, 30, now 35, 40, 45. This marking is 50. This is one lesser than 25, so this is at 20. We need all of this because subsequent subdivisions may need that information. So work out the frequency density for that class. We have found out this is 25. How many babies were born in total? This literally means we'll have to find the frequency for every bar and add them up. Meaning find the area of every rectangle, every bar here. From 3 to 3.5 is 0.5 and this is 30. 30 into 0.5, 15. So 15 babies in this interval. 3.5 to 4 is another 0.5. The height is 50. 50 into 0.5, 25 babies in this interval. 4 to 4.2 is a 0.2. 20 is the frequency density. 20 into 0.2 is 4. So now, how many babies were born in total? You literally have to sum up. 5 plus 15 plus 25 plus 4. 20 plus 25, 45 plus 4. 49 is the answer for part B. Part C asks us to estimate the median weight. Now, when we have tabular data, there are several steps to follow to find the median. Now, from a histogram, how will we do? First, for a median, the total number in question, the frequency here is 49. We just found out that 49 babies were born. 49 is an odd number. When the total is odd, there will be only one median, which is the n plus 1 by 2th item. So 25th item is the median here, which means the value which is at the 25th position. So let us see how to calculate it now. For that, what we should do is, the first bar is 5. The second bar is 15. These two add up to 20, which means our median lies in this third big bar. So, till this bar, it is 20 and we need a 5 more because 5 is the 25th position is the median. So, if we need to find the line, the demarking line here which contributes to 5, the height of this bar is fixed. It's 50. 50 into what will give me 5? Obviously 50 into 0.1. This is 3.5. So from 3.5 if I go another 0.1, I mark it here. So this is my median position, which is 3.6 kg. This is how we go about the median. Draw a frequency table for the data in the histogram. The frequency table is nothing but, first one will be class width. And the frequency. The first one, 2.8 lesser than equal to W, lesser than 3. How many in this? 5. 3 less than equal to weight, less than 3.5, 15. 3.5 less than equal to W, less than 4, 25. Let me go a little down. 4 less than equal to W, less than 4.2. Now W here represents the weight, that's all. 4. Now all this adds up to 49. So this is the frequency table D. Work out an estimate for the mean from your frequency table. Now, we are all aware that mean, median, mode are all averages, different type of averages. Depending on the scenario, we'll have to go with whichever average is needed. We interpreted the median from the histogram. Let us find what mean is. For mean from a tabular data, we know we need a midpoint column, correct? Because we don't have a singular value representing the data. Instead, we have the entire class interval. If we need a single value representing that, let us take the midpoint. So, I am adding that. Midpoint. So, midpoint is x. This is f. We all are aware that we have to find f into x. So, 2.83, 2.9, 3, 3.5, 3.25, 3.54, 3.75, 4, 4.2, 4.1. Now, all we need to do is calculate now. 2.9 into 5. 29 into 5 is 145. So, this is 14.5. 15 into 3.25. Let me put it here. 15 into 3.25 gives me 48.75. 25 into 3.75. Again, let me do 25 into 48.75 gives me, I'm sorry, 25 into 3.75, my bad. 25 into 3.75. 25 to 3.75 gives me 93.75. So 93.75. 4 into 4.1 is 16.4. Now we have to sum up all of this. 5, 5, 10, 6, 13, 20, 24, 6, 8, 14, 17 plus 6, 53, 3, 7, 16, 17. Let me check once again. 13, 20, 24, 6, 8, 14, 17, 23, 3, 7, 9, 16, 17. So, we all know that the formula for mean from tabular data is sigma fx by sigma f. Sigma fx is 173.4 divided by my sigma f should be the total babies born, 49. So, 49. Let us calculate that. 173.4 divided by 49 gives us 3.538, could be rounded to 3.54 kg. So 3.54 kg is our mean estimate from the table. What we got from the histogram is 3.6. You see that they are very, very close by. Now last part. How many babies were heavier than the mean weight? Now this literally means we have to locate 3.54 here on the histogram here, and then from then onwards get the total. We see that the height of this third bar is again 50. This is 3.5. We just need a 0.04. So we have 5 divisions here making up a 0.1. So every division is a 0.02. So it's obviously the second line from here. Okay, so this line is 3.54 that I've marked. Okay, so now what do? We'll have to get how many babies are only in this interval. In the total we have it's 25, but this small piece we have to leave, right? So what we have to do is 4 minus 3.54 is how much? 0.46. So the width of this from this blue line to end is 0.46. 0.46 into, sorry, so 0.46 0.46 into the height of the bar is 50. This gives us, so 0.46 into 50 gives us 23, which means the blue area that I've shaded, there are 23 babies. So this portion alone, from this black line to my blue line here, is 2. So this is 2, this is 23, adding to 25. So these are 23. The last bar we know is 4. So 23 plus 4. 27 babies were heavier than the mean weight. Total were 49. So of that, 27 babies were heavier than the mean weight. This is how you interpret and do a histogram problem in data handling. I hope that was clear. I will see you all in another video. Thank you.